And our answer is we're going to do HTTP, which is the Hypertext Transfer Protocol. So what is HTTP? Again, in a slide or two, here are the basics, because you could read the entire HTTP spec, which runs to dozens of pages. It's captivating, but here's the high order bits. It is an ASCII-based request-reply protocol. So let's unpack that. ASCII-based. That means that when we're sending stuff over HTTP, we're sending plain old ASCII strings. We're going to do a little live demo here, and you'll see some examples of them. Request-reply. That's what I said before. HTTP always begins with a client asking something of a server and always concludes with the server replying. Unless, of course, the network has crashed, then the server might not reply at all. But the point is, it is the client that is initiating stuff. Even if the server tries to reply but gives an error, that is still a reply. The server can reply saying, sorry, can't do that, but it is still a request followed by a reply. Okay? So kind of point number one about HTTP. So what do these things look like? We'll do a live demo in a moment, but an HTTP request is one of several HTTP methods. Get and post are the most common. Uniform Resource Identifier, URI. Sometimes it's called URL for Uniform Resource Locator. Your mileage may vary. We're going to use URI because it's actually a little bit more general, but you have seen these all the time. They're the things that begin with HTTP. And together, these things are called a route. This piece is important because the URI by itself doesn't determine what is going to happen. It is the combination of the URI and the chosen request method, get, post. We're going to see some others. The client also says, when it's making the request, which version of the HTTP protocol do I understand? Please don't walk in front of the camera. Thanks. Which version of the HTTP protocol do I understand, so that if the server and the client understand different versions of the protocol, hopefully they can agree on some least common denominator. The client request will also include some headers, some extra information regarding what it wants to get from the server. And if all goes well, the server will eventually receive that message and come back with a response, which basically acknowledges, yes, I understand the protocol version, and here's the status of your request. Did everything go well? Did it not go well because the thing you're asking for has moved somewhere else? Was there a problem because you're not allowed to get to that thing or it wasn't found? Was there a problem because internally I blew up and I'm very confused and I can't reply at all? The server will also include some response headers with some more information about if the request succeeded, what's to come, and the response body, which is the thing you actually asked for. So if we could do a simple demo of this, let's see if I can get this to work. So I'm going to do a simple request. This is a website that is, oh, I'm sorry, you guys can't see this. Let me change this so that I'm turning on mirroring. OK, now you can see it. So I'm going to use a command line tool called curl, which basically is an HTTP client. It lets me send HTTP requests to a server, and it'll store whatever comes back from the server in a file, or in this case, just display it on the screen. I'm going to use this simple website that is featured in homework 2 called Watch Out for Snakes. I don't know why it's called that, but it generates random words. And we're going to use it in a future homework assignment where you write a version of the Hangman game. That's where you're going to get your words from. So if I just curl out to that server, boom, all this stuff came back. So everything that came back, this is actually the thing that I asked for. Because I asked for it to visit the random word page. I'll actually show you if I went to if I actually visit in a browser. Here, we just go to the home page. That's what the home page looks like. It's not super exciting. And if I do view source in my browser just to see what's behind the page, you can compare that to this raw version that I got back from the server. Now, what if I actually wanted to see what are the headers that the client sent along with that request? And you'll be using the same tool in the HTTP intro homework, so don't worry about trying to copy down how I'm using it. This is all spelled out for you in the homework. So this time, I gave the -i option, which says, show me the headers that the server sent back. OK, so here's an important little bit. The very first line, HTTP/1.1. The server is acknowledging that's the protocol version that I'm using. 200, that's the HTTP code for all is well. I was able to return the thing that you asked for. Everything after 200 on that line is for human readable purposes only. So HTTP 1.1, 200, super awesome, would have been just as legal. And then after that, here's the length of the stuff that I'm sending you. It's 4290 bytes, a blank line, and a bunch of stuff. This is basically HTTP in a nutshell. Right? For a lot of things that you're going to do, this is kind of the level at which you need to understand it. It is not super complicated. This time I ran curl with the -v option for verbosity. And now it shows me both the client headers and the server headers. So these right-pointing arrows, these are the headers that went out as part of the client's request. So what the client actually sent was, here's the route, get this URI, this is the protocol version that I'm prepared to accept. And the client also sent some headers confirming what the host is, although that's optional. It identifies what type of client it is. So for example, sites that do what's called browser sniffing, so that the site can behave differently depending on whether it's a mobile browser or Firefox or IE, will often look at that line. And accept means I am willing to accept kind of any type of data. I'll take HTML, I'll take images, text, whatever you want to throw at me. And then these left-pointing arrows, this is what the server sent as part of the response headers. We saw those before. So the first line of the header is HTTP protocol version, confirming I understand HTTP 1.1, so we're good. 200 is the status code for HTTP that means everything is OK. And the rest of the headers give some information about what kind of server it's running. It looks like it's Microsoft Active Server Pages. The date that the request was made. And here's the length of everything following, which is the actual resource that you asked for. Curl has about 20 million options. It is a little overwhelming to look at, but in the homework assignment, we'll step you through using 2 or 3 that are the most useful for sort of debugging low-level HTTP things as you go. OK, this went back. Cool. So, and one other thing that you'll learn in the HTTP homework is every HTTP request to the same server is actually completely independent of every other. The server has no way of associating them unless there's something in the headers that says, by the way, this is the same client that just visited a little while ago. That's called a cookie. And if you have not worked with cookies before, you'll learn all about them in the HTTP intro homework.